In this video, we're going to talk about two types of logarithms, common logarithms and natural logarithms. So a common logarithm is a base 10 logarithm. So anytime you see a base 10 logarithm, we call that a common logarithm. However, when the base is 10, you don't have to actually write the base. So for example, rather than writing log base 10 of x, we would also write this as just log x. So log base 10 of x is the same as writing log of x with no base written. So anytime the base is not written, we automatically assume that it is a base 10 logarithm. Now, the second type of logarithm is a natural logarithm. And natural logarithms are base e logarithms. So remember, when we're talking about the number e, we're talking about e is approximately 2.7-ish, I always say. So when the base is e, we call that a natural log or a natural logarithm. So rather than writing log base e of x, we instead use the term natural log and we write it out. So log base e of x is the same as, we write it as natural log of x is written ln of x. So we use this ln of x, which means it's read natural log of x. So anytime you see the natural log, we automatically know that the base is e. Now, something to notice before we go on, see how there actually isn't a base written here. We know this is base e because it was a natural log. Whereas on the common log, there's no base written, but we know it was a common log because we have log here. So we know that that's a base 10, whereas the natural log is a base e. So let's try to evaluate a few of these without our calculators. So on the first one, we have log of 0.1. So first you want to notice that no base is written here, so this is going to be a base 10 log. So I'm going to go ahead and rewrite this with a base of 10, log base 10 of 0.1. And I don't know what this is equal to. It's some unknown, so I'm just going to call that x. It's equal to some unknown called x. Now remember, when we're trying to evaluate a logarithm, we're going to start with the base. So here the base is 10, and this means we're trying to find 10 to what power will give us 0.1. So rewritten in exponential form, we have 10 to the x power is equal to 0.1. So now we're solving a little exponential equation here, and I'd recommend rewriting the decimal as a fraction. So 10 to the x power is equal to 1/10. But 1/10 is really the same as 10 to the negative first power. And now we can use that uniqueness property that says when the bases are the same, the exponents are going to be equal. So that tells us that x is equal to -1. So back to the beginning, log of 0.1 is actually equal to -1. Again, we don't want to leave our answer as x equals -1 because there really wasn't an x in the original problem. We were just trying to evaluate this logarithm. So we want to write our final answer as a statement of log of 0.1 is equal to -1. All right, let's look at the next one. We have natural log of e to the fourth power. So because this is a natural log, we know that it is a base e logarithm. So I'm going to go ahead and rewrite this with log base e, and then I'm taking the log of e to the fourth power. So remember, e to the fourth, we call that the argument. So we have a base of e, and then the argument is e to the fourth power. And we don't know what this is equal to, some unknown, so we'll go ahead and equal it to x. And then we're going to rewrite this in exponential form. So we start with that base. This is going to be e raised to the x power is going to equal this entire argument. So rewritten, that's e to the x is equal to e to the fourth power. And now bases are already the same, so we'll use the uniqueness property, set the exponents equal to one another, so x is equal to 4. So you can either go back to the beginning, or I'm just going to rewrite it down here. We just found that natural log of e to the 4th power is actually equal to 4. So this would be my final answer. Our last one is natural log of 1 divided by the square root of e. So like our last example, because this is a natural log, we know automatically that the base is e. So if I rewrite this logarithm, it would be log base e of 1 divided by the square root of e. And I don't know what that equals, so I'll equal it to x. Again, we're going to use our base and rewrite this in exponential form. So e raised to what power, the x power, will equal this entire argument. So that's going to be e to the x power is equal to 1 divided by the square root of e. And then I'm going to use a similar strategy to what I did over on example A here, where we had this fraction of 1/10, and then we rewrote that as 10 to the negative 1. So similar idea in this problem, only I'm going to do it one step at a time. Let me start with the square root part. I know that the denominator, the square root of e, is the same as e to the 1/2 power. And then I'm going to go ahead and rewrite that with a negative exponent. So 1 over e to the 1/2 power is actually e to the negative 1/2 power. And finally, I'm at a place where the bases are the same, so the uniqueness property says that the exponents are equal. So x will be equal to negative 1/2. And again, the appropriate way to write your final answer would be to go all the way back to the beginning and to write that this logarithm is equal to negative 1/2. So natural log of 1 divided by the square root of e is equal to negative 1/2. So the key to evaluating logarithms, it doesn't matter what kind of a logarithm it is to rewrite the logarithm in exponential form.